And welcome back. So continuing on with the database index class and its tests. So now that Dispose has been implemented, where are we going to go from here, Nelson?
All right, so now we can go ahead and start implementing the get first record position method, I guess.
Okay.
So I'm actually going to move Dispose down a little bit, just for my own reasons. But it's Control-Shift-Alt and then down a few times to move that guy out of the way.
Cool.
Because it's just kind of crufty, frameworky method.
Mm-hmm.
And then we move this up because we're implementing it first. So the first thing that we need to do, if you remember from the Photoshop diagram that we had before, is that we need to get the index. And the index is going to be the position within the index file that the index of these coordinates exist at. So I'm going to write var index equals get index, and then I'm going to pass in two integers. These coordinates are in floats. We're turning them into integers because this system was specific, or this formula was specifically designed to work with
ints for
ints, not floats.
Exactly, for the patch coordinates.
All right, so I'm going to go ahead and generate that method, and I guess we can call this x and y. So now we have a private get index method. I'm going to move it down because he's private. So I'm not going to be able to explain the math behind this.
Okay, this is what you were talking about as far as the unique number that got generated based off of coordinates at the beginning, right?
Yeah.
But the cool thing about the internet, you can find really cool formulas on the net, and if you know how to implement them, you don't necessarily know how they work as long as they give you the result you're looking for.
Yeah, pretty much.
Well, let's see this, because I've never seen this formula, so this should be fun.
Okay, so we have, I call it get index 3. Basically, this formula is broken out into 3 different functions.
Okay.
So we have to obviously implement all 3 different functions.
Mm-hmm.
And I'm just using funcs just internally because they're cleaner.
Sure.
And then he's going to do that. What am I doing? We need a parameter list. He's going to take in a single. Let's just call him x2. Now, if x2 is 0, return 0. If x2 is greater than 0, return 2 times x2 minus 1. Otherwise, return negative 2 times x2.
Okay.
And for whatever reason that fails, probably because I don't have a, no, because I didn't do my signature right on my function. Okay, and then there's another function that depends on getIndex3 that I call getIndex2. And he returns a uint. The reason I went with uint is I want to be able to support as many possible indexes as possible.
Okay.
Or within reason, anyway. So we have a getIndex2, and he takes in an x and a y. So he actually takes in an int and returns a uint. So x2, y2. Now getIndex2 simply returns cast to uint math pow. So that's x plus y plus 1 to the power of 2 plus x2 casted to uint, and I'm going to break that out into a single method lambda. So that's just clear.
Mm-hmm.
And then the final thing is that we need to go ahead and return get index 2 with get index 3 on x and get index 3 on y. And I don't think I got my types right. Yes, I didn't get my types right. Get index 2. Wow, now I'm really confusing myself. Get index 2 takes into integers, returns.
But get index 3 only takes 1.
Ooh, yeah, that's why. I had a syntax error. That would explain it. And this actually returns a uint, not an int.
Gotcha.
So there we go. There's our awesome static method that does stuff.
So basically, as we send in all of our coordinates going positive and negative for both x and y, this is going to convert it to that linearly incrementing positive value set that we can use.
Yeah, pretty much.
Pretty much, or yes? Yeah.
Yeah. Oh, yes, that's the idea.
Okay.
Okay, so we have our index. The next step is to get our file index. And the reason we need to get a file index is because, remember, these are all in 64s that are being stored.
Mm-hmm.
So we basically need to take this index and multiply it by the size of a long. And for those of you who don't know, long is an alias for in64. So the system.in64, which is 64-bit integer. Okay, so now we have our file index. We can say if file index is greater than file stream.length, go ahead and return -1, obviously, because that file index has exceeded the length of our file stream, so therefore nothing can exist there.
Mm-hmm.
Then we'll enter a lock on our reader, or a lock on our on our file stream, because we don't want any reading or writing to this while we're doing this from multiple threads. Then we want to go ahead and do reader.basestream.seek to the file index, and then seek origin from the beginning. So this basically says seek this stream to this index from the beginning of the stream. Okay. And then we'll just go ahead and say return out reader.readInt64. So yeah.
Mm-hmm.
Now we can go ahead and run this. And we still get the error because we still haven't set anything yet. But setting is pretty much the same straightforward thing. The first step is we get our index. Coordinates x, coordinates y. Then we get our file index. Then we lock our file stream. Then we have, actually, I don't know how that happened. Then we lock our file stream, and we're going to have to basically do the inverse of what this does. We're going to have to say if the file index actually exceeds file stream's length, then we're going to have to increase the size of the file by that difference. And we're going to do that by entering a for loop. So for var I, and we're going to call 0 out index, because we're essentially think of this like zeroing out a bunch of things, except for we're actually not zeroing out. We're setting anything that doesn't have a value to -1.
Okay.
So writer base stream position. 0 out index is smaller than file index. 0 out index equals size of long. And then we're going to say writer base stream, or writer write out -1. And we're going to obviously want to cast this to a long. There's two ways to do this. I could do this. This will, because if you look at the writer.write overload, we have a bunch of different overloads we can use. I could cast this -1 into a long, but that would be kind of dumb, because that probably would incur, unless the compiler is smart enough to optimize it out, it'd probably incur a performance penalty. Instead, I'm going to use the L right there. Mm-hmm. The L turns that number literal into a long, just like M turns it into a decimal, and the OX prefix turns it into hexadecimal, and so on. So this is important, because if this was just -1, this is by default an integer. And that means that our 0 out index is only going to be writing a 4-byte int to every single one of these positions. We want to write an 8-byte int to every single one of these positions. And then I'm going to go ahead and rename 0 out index just to index so that it doesn't wrap around.
Okay.
So the next step is to finally do writer base stream seek 0 from the end, which means go to the end of the stream. Now we have to write our other condition, which is just going to basically say writer base stream seek file index from the seek origin of the beginning. So this basically says if we do have a file that's big enough, then go ahead and seek to that position anyway.
Okay.
And now finally, we will write out our position. So does that method make good sense?
Mm-hmm.
Now if we rerun this, we get success.
Very cool.
So that is a really cool thing to point out about unit testing. Is I just sat here, wrote all this code without having to go into a console app or launch a website or launch a GUI and click around to find if it worked. All I have to do is hit this one button. And if something's broken, all I have to do is set a breakpoint and tell it to debug. So,
Excellent.
yeah.
All right. Well, is that everything that we need to do?
Yeah, that is. We're going to be adding a method later to the database index, but only for the more advanced stuff. So
Okay.
for right now, this is good.
Okay, fantastic. Okay, well, with that, that is going to conclude this video, and we'll see you guys back in the next. Thanks a lot.